Molecular orbitals show up in the chemical and physical foundations of biological systems section of the MCAT and connect directly to topics like bond strength, hybridization, resonance, and reactivity. This concept helps you understand not just what a molecule looks like, but how its electrons behave, which is exactly what the MCAT wants you to reason through. So, let's break down how atomic orbitals combine, form bonds, and control molecular behavior. Molecular orbitals. When two atoms come close enough, their atomic orbitals overlap and combine to form molecular orbitals, shared regions where electrons are most likely to be found. These new orbitals can be lower in energy bonding orbitals or higher in energy antibonding orbitals. Electrons always fill the lower energy molecular orbitals first because they're more stable. That's what actually holds molecules together. Sigma bonds. A sigma bond forms from head-on overlap of orbitals, usually S to S, S to P, or P to P along the bond axis. This type of overlap creates a strong, stable bond directly between the two nuclei. Every single bond contains one sigma bond. It's the backbone of molecular structure. Even in double or triple bonds, the first bond is always a sigma. Pi bond. A pi bond forms from the sideways overlap of parallel p orbitals. It creates an electron cloud above and below the bond axis. Pi bonds are weaker than sigma bonds because the overlap is less direct, but they add strength when combined. Double bonds have 1 sigma plus 1 pi, and triple bonds have 1 sigma plus 2 pi. On the MCAT, this distinction matters when analyzing bond strength, reactivity, and molecular geometry. Bonding versus antibonding orbitals. When atomic orbitals combine, they form two new molecular orbitals. Bonding orbitals, where electron density lies between nuclei, stabilizing the molecule. Antibonding orbitals, where electron density lies outside the region between nuclei, destabilizing it. If more electrons fill bonding orbitals than antibonding ones, the molecule is stable. If antibonding orbitals are occupied, bonds weaken or break, something the MCAT might test using bond order. Bond order equals the number of bonding electrons minus the number of antibonding electrons, divided by 2. Higher bond order equals stronger, shorter bond. Hybridization describes how atomic orbitals mix to form new hybrid orbitals for bonding. These determine both the shape and the bond angles of molecules. sp3, tetrahedral, 109.5 degrees. sp2, trigonal planar, 120 degrees. sp linear, 180 degrees. Hybridization explains how carbon can form 4 equivalent bonds in methane, something pure s and p orbitals can't do alone. Pi and sigma systems. In conjugated systems, alternating single and multiple bonds create a continuous network of overlapping p orbitals. This allows delocalization of electrons across the system. Electrons can move freely within that pi network. This delocalization leads to resonance, multiple valid structures representing the same molecule. On the MCAT, this concept links directly to aromaticity, UV vis absorption, and stability of biological molecules like nucleotides. HOMO and LUMO. Every molecule has 2 frontier orbitals that matter most in chemical reactions. HOMO, highest occupied molecular orbital, where the molecule's outermost electrons are located. LUMO, lowest unoccupied molecular orbital, where electrons can go during a reaction. The energy gap between HOMO and LUMO determines reactivity. The smaller the gap, the more reactive the molecule. That's why conjugated or aromatic molecules often absorb visible light. Their HOMO-LUMO gap is small enough to interact with photons. Molecular orbitals are the real story behind bonding. They explain everything from bond strength and hybridization to resonance and reactivity. For the MCAT, understanding how orbitals combine and interact helps you connect chemical structure to biological function, especially in organic molecules and biomolecular systems. So, whenever you see a question about bonding, think beyond Lewis structures, think orbitals, overlap, and electron distribution. With that said, here are just a few of our student success stories. Students who mastered these concepts, boosted their scores, and got into medical school. If you're studying for the MCAT, click the link below to get started with your own prep. We help students reach a 515 plus on the MCAT, and we'd love to do the same for you. And don't forget, subscribe to our channel for more MCAT breakdowns like this, and follow us on Instagram for extra tips and resources.